Hello there, it's time once again for Randal Schwartz, that'd be me, to show off something about either Dart or Flutter. Today is going to be kind of a special presentation for me. My younger brother is retiring from many years of having been a music instructor at various levels of school around here, and he's retiring in about a day and a half. And I wanted to show off something that would be something for him to sort of count down the days with. I wrote this program in about, I don't know, about an hour or two, a good long afternoon, I think, about 60 days ago. But since the count will go negative in the next day and a half, I figured about time to get a screencast out of there. So I have a Mac OS version running in debug right here. Nothing pretty yet. What you really want to see is it running. I have a little breakpoint set over here, so let's go ahead and click that off. And then we'll need to get back to that. Okay, that'll be that. And then let's watch what it's doing. And then we'll talk about how the code works. Okay, you noticed a flash of font a moment ago. I'll explain what that was, but this is the current countdown, the live countdown as I'm taping this. Taping, what an anomalous word now in this all digital age. But if you notice here, we have the countdown, and we'll talk about how I broke the time into pieces and do the right thing when it gets to 0. Watch over here. See, it goes away totally for seconds when it's 0. The same thing happens for minutes, hours, and even days. And the appropriate S is missing here, see, it's not 1 days, it's 1 day. So I fixed that too. I'm going to show you some code tricks that I use to make that work. This is going to be Flutter with all of its various platforms. I've had this running on the web, on my mobile device of choice, and also published to a URL that I'll give you later as a web app. So and this is running in Mac OS, so it's an application. But one of the things I really like is take a look at the stars back there. They're randomly generated, fresh each new time. But if I make this wider, watch the relative positions of the stars, and also watch the reformatting of the text inside. Notice that the stars are always circular and are always in the same place in the playfield, and yet they're persistent as we go in and out, and I'll talk about how that actually all works in just a second. Now let's ignore this now for a bit. What's funny is if it's hidden, the stars eventually keep moving and they all move off, but it doesn't create any new stars. Don't quite know why. Don't care. This was a quick project. It's done. So let's go through the code. I hope this is big enough for you all to see. We have, let's see, import Dart Math, nothing special there. We needed the foundation Flutter library because we're going to be doing some things with alignments and sizes to get some positions and relative things. Material, of course, everybody gets. I did this with my Riverpod Hook startup library, startup toolkit. So we'll talk about that in a few minutes. I also, for fun, I wanted a handwritten font, so I went to the Google Fonts package and imported that. I should probably show off the PubSpec YAML to see what we actually have in here. Let's go do that. That's down here. And if you'll see, the unusual things here are Flutter Hooks, Google Fonts, and Hooks Riverpod, which are pulling in my cool stuff that I want. But that's not interesting now. Let's go ahead and go back to the main thing. Now, my Riverpod starter kit starts like this. It does a run app around a provider scope. And you'll notice a lot more consts in my code now because the new Flutter lens actually shows all the constructors, the Flutter constructors that can be used with const. And there's so many of them. And I know that speeds up operation a little bit. So I'm really happy that there's a lint for that, although it was annoying on the first time I saw it. My top level widget is a hook widget, like all widgets are in my job of stamping out all the stateful widgets I can, because a hook widget gives me the ability to have state in a totally different way. Run count key, this is all core stuff. To get the handwriting font, I had to do a few steps. First, I get the default text theme, and this is theme of context text theme, okay, which gives me the whole text theme for it. That's actually like all the 15 different things, like headline 6, headline 5, headline 4, down to text 2, that sort of thing, body text 2. Okay, so that's the default one, because I wanted to mostly have the default one, at least in terms of the sizes and the various things. I'm going to do a Google text theme because I'm going to use the Google Fonts package. Well, Google Fonts has quite a few things in it. We're going to get the text theme called Caveat Brush. Now, I'm actually getting this from a web call. I don't have the local font in my assets, and I wanted to do this to demonstrate that I could put it up on the web and not have to go fetch that in any particular way. So that's my default text theme there. Okay, and then we have our text theme, which I take the Google text theme, and for demonstration purposes I want the body color to be white always, and I want font size factor to be 4, which means that instead of the normal sort of 14-point type, it's going to be 4 times that in the body text size. Okay, I then I turn off that wonderful little slash, because when I was developing it, I didn't have the release version yet, so the slash was in there. So that no, get rid of that debug mode thing. Okay, and again, the theme has a text theme. The background color, I tried to pick something sort of darkish sky, you know. That was pretty straightforward. And the text theme is our text theme that we just created up here. The home is down here in the home page, and it doesn't have any input parameters. It's also a hook widget, though, like all of them are in my code on this program, and in a lot of my other programs now too. Same thing we had before in the Riverpod starter kit. There's the child, my page. Excuse me, my throat's going away. Of course, now I'm trying to do this, I don't have a throat. Okay, so we're almost to the unique stuff about this particular program. So what we want to do is use animation. So normally when you use animation, it has to be a stateful widget. You have to create the animation controller and the animation that works with that in your state. And the reason for that is that it has to persist some information across builds. And but Riverpod and Hooks to the rescue, we use this animation controller with use animation controller, and that comes in as an extension when we bring in hook widget instead of stateless widget, which is what I have now. The hook widget is essentially a subset or a subclass of stateless widget. Okay, now what this gives me is it gives me in this spot an animation controller, and it uses these parameters to initialize the animation controller. But the good thing is I don't have to dispose this animation controller. It just lives until it's no longer needed, then it automatically goes away. That's what use animation controller is doing for me. It's not for me not to need a stateful widget to hold that animation controller or forget to dispose it when it's done. And I just made it 1,000 days. I just want this thing to run and to tick for as fast as it can for as long as it can. 1,000 days is probably much longer than anybody would ever want to watch this, and especially given a day and a half, it's over with. And I also start the ticker forward, so that's basically going to give us the animation. And then this doesn't actually set up any rebuilds, because all this does is create the ticker, but it doesn't actually cause this widget or the child widgets to be rebuilt as fast as the ticker goes. So we have this other thing called use animation, which basically takes the animation controller that I just created, but it would take any animation controller. It wouldn't have to be this one. If I wanted to use some other custom bespoke animation controllers, I could use that right here. But what it does is it hooks this ticker controller into the rebuild of this widget. So now I've effectively subscribed to it. And it also returns the animation type T here. So whatever I set up for an animation controller, let's see, I don't actually know what type this ticker controller is. It is animation. Oh, I just didn't say it. So I could have like a num or something there for the type, and it would end up doing the right thing. But I'm going to get the value out, which I don't really care about. It's just a value. And I can define what that value is. I think, let me experiment here. I think I can just go double. Double, D-O-U-B-L-E. And, yeah, so now it's going, use animation is returning, still a T. Oh, well, doesn't matter. Let's undo that. I don't want to mess up anything now. Okay, good, because this works. All right, now this gives me sort of the heart of the program in that we will be ticking all the time. So we're going to take a layout builder so that I can get the box constraints for the full width and height of my viewport. And then I'm going to return a custom paint. You'll like this, so we'll get to that in a minute, where it's going to paint those stars on. And then there's a child which will sit above the level there that's going to be centered with some padding, and the marquee is the thing that's actually drawing the text that says how many days, hours, and minutes it's going to be still. I want the size of this custom paint to be the biggest thing I could possibly put on there. So this is going to make sure the canvas that I'm drawing on is edge to edge in both directions. Okay? So that's sort of my place that I'm scribbling is in there. So let's see first, though, what is the text in the front? How am I doing this? Well, I've got my hook widget for the marquee. Same things as before. This is the time as a daytime, and daytime UTC actually, of when my brother Ron is retired. And so I did the math, and because we're currently 7 hours away from UTC, I took the 3 p.m., 15 hours, right? 1500 hours. And I add 7 to give me the right number. What's funny about this is that 15 could have been 22 to be 10 o'clock at night, and that plus 7 would still work without changing the other numbers. So that's a really handy thing to know about UTC calculations, is that if they roll over, if they wrap over, it still works. So very handy for that. Same thing with month and day and all the other things. So those all wrap over when they need to be. But here's the big time coming up in just a couple days at 3:10 p.m. local time, which is UTC minus 7. And this was the calculation to bring it in line with that, so now I have a date time there. Okay, then just for convenience, I create a second subroutine inside the build subroutine, right? Here's the build, normal context, with a slight bit of additions for a few things for Riverpod. But we have here S. This is the name of the subroutine. It takes a number and it takes a text. And all it does is takes the number, stringifies it, takes the text, and then puts an S after it if the number's not 1. Now, this little thing I had written in multiple places down here, and I was thinking, why don't I just write a quick subroutine? So don't be afraid of that. Don't be afraid of writing these little helper subroutines that are only really needed right there to assist you along in your code. Really nice. Now we get the difference here between now and when it's going away. So this math is subtracting date time now from this time in the future. And it will go negative as a negative duration. That's the result here. It's duration. It will go negative after the event, and we'll use that to notice when we should print up the splash page finally for yay. Actually, I don't do very much exciting here. I'll probably fix it before Wednesday, so if he's actually watching, he'll see a big animation or something. Okay, so then we start doing math. So we take the time t, which is how many seconds away that is, and then I do some fun stuff here. I basically don't want to change it every second. It got really busy when I was doing that. So I want to change it every 5 seconds. So if we go back here, you'll notice, see the stars all eventually floated off. Now it's making new stars. And that's because, there's why. That's because when it's off the screen, when it's not actually refreshing, the animation is stopped to save your batteries. And because all the other stars that existed before have a ultimate end time, they're going to go poof and go off the edge. They eventually are all way out over here to the left. You can't see my hands waving, but way over here to the left. I can do it with the mouse. Way over here to the left. And that means that they're no longer visible. So I'm not making new stars because the ticker's not running. And I'm not getting, and all the old stars eventually have wandered off. Okay, but notice here again, we're only updating every 5 seconds. And it's a lot more friendly. So keep that in mind when you're trying to build good user experience. Don't tick it every second because it's not really, doesn't need to be that accurate. And if I'd had a little more time, I would have used a couple of the animated text packages that I just discovered to kind of slide that text in and out and change it with a smooth move instead of doing the hard thing, but that's okay. And just for fun, I also clamped it at 0, so if it was less than 0, it would get clamped to 0, because I don't want to go negative values of the duration. It doesn't matter. And then just some basic math to get the seconds, minutes, hours, and days as integers for each of those steps. Okay, now here's something that some of you might not be aware of. This is just a list constructor, square brackets, but it's a list constructor that can either add or not add to the list items based on whether this expression is true or false. So if we have days, 1 or more, right, greater than 0, then we put in days as the count, and then it's the word day, possibly with the S added because of this expression up here. Okay, same thing with hour, minute, and second. So what I end up with is a 0, 1, 2, 3, or 4 element list. Okay, 0 if we're past time. If it's already off in the future and he's off golfing at the next door golf course and all the other things he's planning on doing in his retirement, traveling the world, things like that. I got him beat on that one. So anyway, we've got the different times here, right? Now, we have something that will look like 1 day, 3 hours, 5 minutes, and 20 seconds. 4 parts. But now we want to glue that together in a nice English way, a nice way that's appropriate for English. So first thing we're going to do, though, is if nothing shows up in that list of parts, hey, it's done. He's out of here. So Ron retired. That's all it says right now. It just means right in the center. And I tested it by moving the buy time to much earlier. Okay, but next what we do is we create a string called say, which is going to be what we're saying. To test it, I made the parts A, B, C, and D, and then commented them out and shortened them like that. Okay? But now, there are 2 camps on whether the comma belongs before the and at the end, or whether the comma doesn't belong there. And there are arguments for both sides. I wanted to make it easy to talk about whether you need the serial comma. But initially, we don't need one because we don't have any parts yet. But if the length is greater than 2, we take the first part and add a comma space as text. And that's while, because we're going to take the parts off one by one. This is For me, it's a shift in Perl, right? And a shift in the shell and a few other things. So it's basically take the first item off of the list. So this is destructive to the list. Okay, it has to be a mutable list for this to work. And so we take that first item off, and we add a comma space. Now we know there's at least one more item because this is as long as the length is greater than 2. So it's going to be there. And because we did have at least one item and one comma, we say serial equals true. Now, if we comment that out, we will get 5 minutes and 15 seconds without a comma at the end. And if we leave it like it is now, it'll be 5 minutes, comma, and 15 seconds if there was at least something before that, because the length had to be greater than 2 in the first place. So that gets all that correct. And yeah, I worked at this a little bit trying to figure out the right way to do that. Actually, I cheated. I looked at some Perl code I'd written to do this many years ago, and it was still useful. It was simple to translate from Perl to Dart for me. Okay, so now when we get down to here, the length could be 1 or 0. We don't know yet. But if the length is 1 and we want a serial comma, we put comma space and. Otherwise, if we don't want a serial comma, we just put space and space. And that does the right thing. And again, shifting off the beginning of the array to get stuff to add to say. And notice I'm using the plus equals on strings. It's very JavaScript-like, but it worked real well for me. Again, I wrote this very quickly too. I probably could have figured out some package that I could download to do this commaization, but it's okay. So now here's the text. Ron has say until retirement. And for grins, I was looking at TixX, which I no longer have in here. This was when I was generating all the individual numbers discretely, and now I'm just letting the animation take care of it. Much easier. I should have done that to start with. Now those stars, you may wonder. Those stars are basically a set of stars. Okay, this is slick because we have essentially no order to the stars. It doesn't really matter that a star is up or down or left or right from another star. We'll talk about how to generate the stars in a minute, but this is a set of stars. And star is my own creation down a few lines below. Okay, so now for the star painter. This was referenced up in the CustomPainter earlier. Okay, not the CustomPainter, the, let me get this right, the, a little further up, yes, the Custom Paint. Right, Custom Paint is the widget. Custom Painter is what draws on it. Okay, so that's our Star Painter. Now we're back down here again. So we got Star Painter. Yay. And then we have to override the paint and override the needs painting. We'll do that one in a little bit. And it gets the canvas in from the hierarchy of Custom Painter. And it gets the size, and the size is what I passed in. It was that size that's there, right? Okay, so we've got now, which is going to be a date time, and we're going to need that. Now, we want to add some random stars on the right-hand side. And so I just use my function roll, which all it does is if you give it an arg, where's roll? Down here. Don't look at this other stuff yet. I'm not supposed to look at that yet. I was just scrolling down to find roll. There it is. Okay, so roll takes random next double, and yes, I'm creating a new random every time I invoke this. I know that's not cool, but it was like I said, straightforward and easy to do. And I also pass in a by if I want a multiplier, so it's 0 to almost 1 mostly, or if I pass in 4, it's 0 to almost 4. So that's the value there. Okay. So what I'm doing with this is I'm taking 0 to almost 1 and comparing it to 0.03. Now that's approximately, but randomly, 3 times out of 100. So for every 100 cycles, it will be, it's probably easier to do it with 60 cycles because this is mostly 60 FPS when I was looking at it with the animation. So that means that we'll generate, well, maybe that's not any easier. We're going to go through this 60 times. So it'll be like 18 stars every 60 frames every second. 18, it can't be 18 stars every second. Okay, I'm doing the math wrong. I don't care. Anyway, 0.03 was about right. I just kept tweaking that until it looked right. And then what we're doing is we're creating a star. This is a constructor that's going to return back a star. And I pass down now just because I need it for birthing the star to know where its initial time of entry on the playfield is. I could have just as easily done daytime now down below, but this just saved me one step. And I'm going to add to what's initially an empty set, stars, I'm going to add this star. Now, elements in the set need to be compared with equals, right? Well, I think I fixed that. We'll see. Maybe it doesn't actually care even. I can't remember now. I haven't got to remember to read down it. Now we do some things that I saw in a lot of basic how to draw with a CustomPainter tutorial, so I won't go into too much of this. I want the background color to be this color, and I'm going to draw the entire background with this paint. Now, this is crazy because I have also already set up my background color further up here. Let's see, right there. See, I have my background color already that same color. So I don't need to actually paint. So I'm actually wasting time by painting this over and over and over again. Oh well, that's pretty fast. That's a quick fill. Now we get this color of the stars, which I pick sort of at random. A nice yellow, nice pretty yellow. Next, what I want to do is go through the set of stars and draw each one of them. Now, if I said for S in stars, it would work. It would basically run through all the stars that are there. But we need to make a copy of stars, and I'll show you why in a second. Actually, it says it right there, so we can modify the original. We then take the star, and we take our now value, and we compute what alignment is it. Now, I might as well describe the star class at this point. So we've got down here the star class. It's got this constructor, but we'll get to that in a second. I use alignments. And the reason I use alignments is because those are scaled to -1 to +1 on each of the width and the height. So what that did is by using where it was on that 0 to 1, on the -1 to 1 scale at birth, I don't have to scale it yet to represent the playfield. That's actually done with a nice slick trick, which we'll get to in a moment. But basically the alignment, and this is usually on the right wall. We'll see how that ends up when we do the complex math up here in the right wall thing. The right wall, of course, would have a horizontal alignment of +1. And so we'll end up popping a lot of points over there, and we'll see how that actually works. Okay, so that's going to be that. Okay, and this is the birth time. That's going to default to the time of day that's passed in. This is the screen in screen pixels. So this is the size of the thing. And it's, yes, it's screen pixels because it's the points of the screen. Okay, and then the speed is also an alignment. Look, both of these are alignments. And again, it's because I'm using alignment of -1, 0, which is left, directly left, to be full speed left. And I'm using, -1, -1 to be sort of up and to the left. So they all have interesting values here according to the description of alignment. So so this is really a vector that has at most a unit length. Actually, it could be bigger, but think of 1 and -1 in both directions as being sort of 1 unit in that direction. So, and I'll be adding that to this with a little bit of math. I've got a toString for diagnosis, so I won't go into that. Basically, just do a lot of the normal things. But now we want to know, and this is what the code up above calls, is it calls alignment at a particular time, which is now up above, and I'm just passing the now down here. So watch what's happening here. So we're taking datetime now that's being passed in and subtracting the birth time when I created the object. We'll see how that works in a minute. And then I get in milliseconds divided by 1,000. So that's a 3-digit accuracy floating point value of seconds old. How old is it? How long has it been on the screen in terms of seconds? Okay. Now, I take that and multiply it by the speed. So the answer I get out of there is an alignment that is scaled by the time that it's been alive and the speed it was going. And what, of course, is rate times time? Hey, it's distance. So that's the alignment representing the distance from the center of the screen to wherever it needs to be at the moment. So that's pretty slick. All right. Now, let's go about creating one of these things. The only constructor I have is that it's going to be points on the random right side at this particular birth time. So I'm passing in the birth time as the single parameter. And that was now, for you remember from up above. Okay, so now that gives us the birth time. The birth alignment, now what is that? That's where it is being born at the time of that birth time. So it's actually pretty slick. We're going 1.05 for the X. Well, that'll be just off the right edge of the screen. Okay, because remember the screen is going from -1 to +1. So that's just off the edge of the screen. And then I want a number that's centered on 0 but goes from -1 to +1. And that again will be something along that right wall. If it's 0, so if roll 2 minus 1 ends up 0 because roll 2 showed a 1.0 minus 1, that's 0, right? And if roll 2 is 2 minus 1 is 1, that'll be the bottom right corner. And if roll 2 is 0, then it's going to be -1, which is going to be the top right corner. So all of these points are along the right-hand wall. And that's why all those stars come sliding in from the right. Okay, now let's keep going here. We've got this speed, and it was a little trickier to work out. So the X value here is, again, per second. How far of an alignment do I move to the left? So that's random up to 0.01 plus 0.05. So it's not much change in the speed. They're mostly the same speed. I've tried it with more differences, and it just got chaotic on the screen. So again, this is one of these things that sometimes when you're making art like this, you've got to kind of try different things over and over, and thank God it's easy to just hit, refresh and tweak different numbers until the number looks really about where I want it, and works really well. The only hard part was that the stars would disappear on a restart, a full restart, but they would stay there on just a hot reload. And that's because I defined the star map, the star set outside at a global level, so it just hangs out because it doesn't get reset on a hot reload. Okay, and that gives me the XY, or the value going to the X. So that's biased towards the left at a nice clip, 20 units, 20.20, whatever. Anyway, that amount right there. It's getting late in the day already. Okay, now let's look at this though. So if this is the left-right speed, biased slightly negative, then this is the up-down speed. And here I'm going between 0 and 1, subtracting 0.5, so it's evenly biased up and down. And I divided it by 20. So that's going to give us a number between -1/20th and +1/20th. which is the deflection up and down, because this is the Y slot instead of the X slot, which gives us that sort of slight drifting in slightly different directions. Again, make this value too big and you just have stars going everywhere. You know, almost like just sprites heading everywhere, pixels and stuff. So that's leftish. That's what I came up with. Size, roll 3 plus 1, turned out to be experimentation once again. Roll 3, of course, is 0 to 3, and we add 1 to it, so we get 1 to 4 for the star sizes, and that seems about the best pleasant amount for this. Again, this is all art, but look how easy it is to express the art and how to work the formulas together and put those all in. I think I've got everything down here now. So birth alignment is doing our scaling of taking the birth time, difference between that and now, computing out a number of seconds that it's been, and multiplying the speed, but then adding the birth alignment. So what are we getting? We're getting a sum of two alignments, which itself is an alignment, which is basically the offset. So this will be birth alignment's the initial place on that right-hand wall, and this is the distance now to add to it to the left to put it somewhere on the playfield. Okay? Pretty slick, huh? All this in like an hour, hour and a half. Well, maybe 2 hours. Okay. So, because I was solving a few problems I hadn't solved before. So, we now know how the star gets added. We're starting to look at this, walking the stars to draw each one. Now keep in mind, in every frame, we're starting with a fully blank screen. Oh, that's why I had to do that, because I was painting over the previous screen. So this all had to be blacked out again. Okay, now we've got paint color, right? Maybe that's not right, but I'll probably figure it out right after I stop this screen recording. But here we go. So now we want to get rid of the stars that have gone away, gone off into star heaven. So we take the alignment, current align. Notice we got that from alignment at, right? That gives us our current position. And again, in the relative terms, -1 to +1 for X and -1 to +1 for Y, representing when they're both plus or down the lower right corner of the quadrants. Right? Okay. So if the X absolute value is less than 1.1, then we know that it's somewhere along the width of the playfield. Okay? If we do the same test with the Y of the alignment and test it against 1.1, that means it's within, more or less, except for right off the edges, the height of the playfield, because I'm using 0, 0 as the very center. Wow. So this gives me, has it gone too far away yet? Now this might happen fairly quickly if there ends up being a star that's coming in from the right-hand side and then immediately goes up to the right. Then that's going to hit that vertical 1.1 pretty quick. So this is not a constant time on the screen. It really depends on the distance and where it's placed and the speed that it's taking up. Always straight lines, though, because I just did that math once down there, okay? Now, if it is on the playfield, we compute the current offset, and here's one of the clever things here. At the top, we got the size in. That was a constraint on the canvas, right? Remember that? So we have the size, but it turns out there is a method we can call called take the alignment, call a long size on it. Now, that's essentially a matrix multiply, one-dimension matrix, with the two values of X and Y. And what it returns back is an offset. This offset is this size from the upper left to the lower right corner in pixels multiplied by and offset correctly with putting the 0, 0 alignment in the center of that size, or the -1, 0 alignment will end up being the left-hand center, right? And you can do all the combinations yourself. Basically, this scales it now to points. With, again, 0, 0 is the upper left of the full grid for that size. And 1, 1 as an offset is going to be now the bottom right corner, the full size of the size. That's slick math. Boy, I see people doing this the hard way in animation programs, and it just drives me nuts now in their custom painters. There are ways to do all sorts of computations like directions and polar arithmetic without ever touching anything in the math library. That is cool. So you could just put all that behind you, just do this. In fact, we did import math, but only for random. I didn't import math to do any of this calculation about the locations or the speeds or anything like that. Didn't have to. Use alignments. Use offsets. That's what this painting stuff is meant to use. So, in fact, here we go. We're going to get, on the canvas, we're going to draw a circle. This is for the star. Current offset is going to be the center of the circle. And we're going to use the size from the size. Now, the size wasn't scaled. So the stars are 1 to 4 pixels no matter how big the canvas is. That's because it didn't really change, didn't really mean anything. And Star Paint, I think, was up there somewhere. Let's see, where is Star Paint? That's up here. I know I just created it probably right here. There it is, right there. So just the color of nice, pretty yellow. Okay, so that's painting it in yellow. A draw circle is normally filled. And I used to do this other stuff of doing all the scaling and stuff, but this was much simpler. So current offset. It was originally the current pause, but that was 0 to 1 in each direction, and I had to then multiply it out, and it ended up making a weird circle. Not needed anymore. I could probably just get rid of that line. Yeah, that's legacy code. Don't need it anymore. Okay, now, yes, if the star is still on the board, we paint it. Otherwise, we've got to remove it from our set. It has gone bye-bye, off to star heaven. It's now gone. But when I first wrote this code, the first time a star disappeared, when I was iterating over just stars here, it said you can't remove something from a set that is being iterated over. But thanks to this new spread notation, relatively new, in terms of the Dart lifecycle, it's relatively new still, to me, at least. But basically, this says take stars and interpolate that into the list that's making up the next set constructor. Well, that's going to be a copy of all the stars. So the remove of S means that we're deleting that star. Oh, and actually that's okay. It's just using identity equality, not any kind of complex double thing, because double equals is fine. I want to remove the very specific star that I constructed that one time. Perfect, perfect, perfect. Not a problem at all. So we don't need to, if two stars had exactly the same start point and the same velocity, it would only delete the one that I'm currently looking at. Of course, by the time I get to the other one, that's also going to be failed for the same reason. But it will only delete the ones that are actually themselves off the grid. Okay, did I cover most of it yet? Let's see. Just do true. Even with true, it's doing 60 frames a second. You would normally optimize this if you knew that your painting would end up looking exactly the same. Well, I have moving stars, so those stars are always going to be needing to have a different position. So I know that I'm just going to give it true for the response here. And I think that is about it. Is there anything I really didn't cover? I basically made a extension on alignment so that I could just pass an alignment into a string. So there's our birth alignment. So it gives me one set of sizes and so on. Now these were actually only used when I was doing debugging. I would add debug print and an alignment somewhere, and I would see it all scroll crazy down over and over again. Well, I think there you have it, and we can watch it one more time as the stars come back on to the screen. And there we're now down to, let's go ahead and make this really wide because it's kind of pretty. So again, now that we look at the things that we saw before, there you go. There, notice that the little star here is constantly going the same direction, same speed, but different speed pretty much than everybody else. And right now it's still in that set. It's in that set. And right about now, when it gets about a half a unit above, it's going to be off the set. And the set, it'll remove from the set. So one of the things I was watching sometimes in debugging was the stars.length to see how many items were in there. I wanted it to be a comfortable number in the middle. Like I think it's around about 100 here. Right, the count of all the stars. And it would go up slightly and down slightly because it's all random numbers coming in and all the speeds are all random. So, of course, it's not going to necessarily be there. Well, I hope you enjoyed this walkthrough of a real application because I did have quite a few things to show off there. I showed the Riverpod hooks being used to actually set up my animation up here. I showed you a CustomPainter. I showed you, so there's the animation to make it tick at as fast as it possibly can and rebuild that for that time. And then I showed you this wonderful little thing about a list constructor that had basically conditionals for the 4 parts. And showed you a subroutine that's only local to this other subroutine just because I needed it to cut out some common code and so on. Now, if I was really smart, I'd move this out into something more like a common file to import. But I didn't need it for this. So that was all I had. All right, so we are pretty much done with that. Like I said, I hope you enjoyed it. And notice the stars went away over here that while I was talking. Because now what's happening, of course, is that the animation isn't running. So nothing was actually moving while it was hidden. But because the time for this one star here at the trailing end is that much more advanced than the times of all these new things, there is a gap in here. And that's natural to be expected based on the algorithm I use. All right, well, click on all the things, thumbs up the things. I'll be watching the comments as always. Got another 45 things to do in my list, but I had to do this one first because it is timely. And until next time, enjoy.